So, and that will continue on for infinity.
What? I'm sorry. What do you
Uh-huh.
mean by touching the plane exactly?
This line down here, this main line down here.
Okay.
Okay. It will, so this tail will just continue on forever.
But
Okay. Yeah. And really what that tells us is that, um, that it never stops. There could be somebody, however very unlikely, there could be somebody out there with like a 5, or right, even smarter than Einstein. Okay. So I guess because if it touched it, if it eventually, smacked into it, then we would know, okay, that's where the distribution ends. Okay. But it doesn't, it goes on for infinity. So there could be other people out in those tails beyond Einstein, if you want to think of it like that. Does that, did that
yeah.
help?
So
Yeah.
yeah, it's just based like again. So let me repeat myself.
Uh-huh.
Asymptotic simply says is defined as the data or the amount of people, wherever you're calculating, will keep going. Will keep going down the plane, but it will never cross the plane. Like that's where I'm like very shaky about the crossing the plane.
No, yeah. And I guess again, just because this is all um, in theory, right? This is all theoretical.
Uh-huh.
Um, Let me see. Let me do this rather than me try and write it, because
Yes, yes, yes.
you can read this better. So this
Okay.
is the actual definition from the book. Um, so let's see, I keep missing it. Line that continually approaches. But never reaches, oops, where are you? A specified limit.
Okay. Pushes but never
Okay.
limits. Okay. That I can kind of see now the idea. Okay.
Okay. Yeah. So that tail, that line, right, approaches but never reaches a specified limit. And I like that definition better than the one that I always remembered about a line approaching a plane and never crosses it. Because yeah, I guess that idea of a plane is somewhat arbitrary, right? Or we were like, what? So this tail is going to continue on forever. Okay. And it will just go on for forever. Okay. And again, for our knowledge, what this means when we're looking at um, a distribution like this, that most people, because we're talking about the mean, the median, and the mode, most people are in here, right? Most people are all in this area. That's where you could fit tons and tons and tons of people, right? There are more people out in this area. Oops. And then even fewer people out in this area. Okay. This is how we divide up a normal distribution. Okay, my lines are a little off, but so again, because this is mathematically defined, okay, some really smart people sat here and came up with this. If you want to, his name, I can't, oops. And I don't know how to say it because I did not take French in class in high school. Demoivre. I don't know. He was the first one that started defining and thinking about this distribution. His looked a little funnier. It was something, looked more like a spider web kind of distribution. But he started figuring out that there's certain probabilities with events happening. I have no idea. I'm not even going to pretend to know how someone's brain starts thinking about stuff like that. I don't know. But he started thinking about that stuff and saying, okay, there's certain probabilities of events that could occur. And then he became really popular with insurance people and gamblers because insurance people and gamblers both like to know the probability of an event occurring, right? So if you're an insurance person and you're going to insure somebody, you want to know the likelihood that this person is not going to get in an accident and cost me a lot of money, right? Or, of course, if I was a gambler, I would want to know what's the likelihood of this event happening so I can go bet on it, okay? So that was kind of like the history and where this normal distribution comes from. Obviously, it's been refined. Other people came into play, and now we have this distribution that we know about. But there are still probabilities within here, okay? So let's move on to this slide. And I know this is really small, okay? I couldn't make it much bigger for you guys. If you have your book, it is on pages 386, you can see up there. Okay, 386 and 387. Okay, if you don't have it and you have a PDF or something like that, maybe you could print those pages off if you would like, or you can always go back and just reference it. It's not a terrible big idea, you know, like problem to do that. Okay, so what are we looking at here? What is this? I'm going to make this a little bit bigger.
What pages did he say it was?
So 386.
Okay, 386 and 386 to 387.
Just those 2 pages right there. Okay, just these 2 pages. So what we have here, we're looking at a lot of numbers, right? And all of these numbers in here are proportions, okay? And they're proportions in the curve. So I'm going to draw another distribution over here. Oh my God, that one is really bad. Okay, let's see. We just watched Jumanji again. I'm telling you, I can watch that movie a million times over and over and over again. So that was my horrible Kevin Hart. Okay, let's see. Oh my gosh, that did not get any better. Okay, so here's a distribution. And let's draw this line right here that this would be the mean, okay? And this is giving us proportions, okay? Pieces or the proportion of people in a certain section of this distribution, okay? So right here, column A, these are all your blue columns, are the z-scores, okay? Column A is all of your z-scores. Column B, you can see right here. Column B is the mean to the z. The mean to the z. So let's see. I'm gonna pick one right here. Let's just do this one. Point. So thick it did too, but that's all right. Let's pick a z-score of 0.10. So it's really tiny, right? Please be advised, none of my things are drawn to scale, okay? So a z-score equal to 0.10, okay? I realize now I don't want both of those on there. So we did a z-score. And if we look in the B column right here, we see 0.0398. What that means is in here, the proportion is 0.398. That's the proportion in that little sliver from the mean to the z-score of 0.10. Okay. What column C tells us is the proportion that's left in the tail beyond that z-score. So what that means is beyond the z of 0.10, it's everything in here forever and ever. It's everything beyond that z-score of 0.10 and continues on into the tail. And they say that that proportion is 0.4602. Okay. So the A column is whatever Z you're looking up. The B column is the proportion in between the mean and that Z-score. And then the C column is from that Z-score to infinity and beyond. It's like Buzz Lightyear, okay? Look, I even picked the colors of Buzz Lightyear. It's to infinity and beyond, okay? It's everything beyond that Z-score in that tail. Let's do another example, okay? Let's go on this one. On the next, I'm going to go on the next page and just so we can maybe zoom in a little bit and see the numbers a little bit better, just in case if we have anybody that's struggling like me to see those little bitty numbers. Okay, so does somebody want to pick a Z-score that you can see on here? No, it's not that much fun. I don't know, my eye kind of went to this one right here, 2.37. 2.37 right here. Let's do that one. Okay, let's do a Z-score of 2.37. Our mean, oh my gosh, our mean would be right there, mean. And then, I don't know, 2.37 might be right about here. We don't have to be exact, okay? So now, let's see, we'll follow the same color scheme just so we don't get too confused. The B column is showing us from the mean to the Z, okay? And so that's everything in here. We can see that that proportion got significantly bigger compared to the last slide, right? Because the last one, we were talking about a Z-score of 0.10. It's so close to the mean, right? It was so close to 0, so it was just this little sliver in there. Now we're talking about a Z-score 2.37. It's significantly further out, and that is reflected by this proportion here, which is 4911, right? The C column is everything from that Z beyond and in here, okay? And it tells us it's 0.0089, okay? So we could put B, and we could put C, right? B column and C column. This table stops right here at 4. Okay, this table stops at 4. It says, I don't go beyond a Z-score of 4. Okay, you'll be really hard pressed to find Z-scores that go beyond a Z-score of 4, but they do exist. Okay, let's see. I'm sure there are questions. So let's see, who has a question?
Well, we have on the exam, will ask us which one is the B and the C scores.
Yeah, so some popular questions for stuff like this would be, I'm gonna type it because you don't want to see me trying to write it. Let's shrink that down a little bit. Okay, so something like this: given a Z score equal to 1.78, what is the proportion I don't know, this is hard part how to word it. What is the proportion between, or to the mean? Maybe we'll say it like that, to the mean, okay. Oops. And then we might have a question, what is the proportion in the tail beyond the Z-score? Those are kind of, they're not worded very well. I promise on the test, they know how to word those things. So let's do this. Let's see. So it says, given a Z-score of 1.78, what is the proportion to the mean? And then what is the proportion in the tail beyond the Z? Whenever you see anything about in the tail or beyond a Z-score, that one's talking about which column? C, right? Good, right? Whenever they're talking about the proportion between the mean, they're talking about B, okay? So now all we have to do in my class, when I was face-to-face with people, I would always just say, this is where we practice our finger sliding skills, okay? So we just have to slide our fingers to find 1.78. And there it is, right? There it is right there. So here's this B column right here. Oh, wait. You guys got them? You guys probably already did it. You're faster than me. Oops. So there we go, right? I don't want to, oh, there we go. Let me get back to my typing here. Okay, so that one is what, 0.4625? And then this answer here would be 0.0375. Can we see that? Where we got those? There's some cool things. I mean, I don't know if it's that cool, kind of cool, about this normal distribution here. If you notice, there are no negative z-scores on here, right? Where are all of our negative z-scores? Where did they go? They don't have to be on here because the normal distribution is symmetrical. So whatever's true on this side is true on this side. So in the upside down world, right, in the negative world, if we had a z-score, oops, oh gosh, that was so bad. If we had, because it's not even like even, it's not even symmetrical. Okay, right there. If we had a z-score of negative 2.37, it's the same proportion. You still have 4911 on this side. And you still have 0.0089. Oh gosh, that was bad too. In the tail beyond. And these numbers, these values here, these proportions, they're not negative because you can't have a negative proportion of people, right? You don't have a negative proportion of people. So the numbers are the same. And what this is telling us is that about 0.4911 people are from the mean to the z of 2.37, and there's about 0.4911 proportion of people from the mean below to a negative 2.37. Okay. There's a lot more we could go over on this, but I feel like this might be kind of enough for today. How about I put up something where you guys just practice going over and kind of finding these different proportions and just practice our finger sliding skills. Okay. One thing I do want to point out, some people might be looking at this and already starting to see some interesting facts. So this whole, let's see, well, oh gosh. This side will always add up to 0.5000. You can check all those numbers there that we've done so far. B and C will add up to 0.5000. Okay. What's true on one side is true on the other. Therefore, this side will also be 0.5000, which makes the whole thing 1. Okay. The other thing you can do with this is you can take these proportions and turn them into a percentage. I don't remember a lot from math, but one of the cool things I did like from math was I remember all you had to do was move that little decimal over 2 spots, right? Do you guys remember that? All you had to do is 1, 2, right? I was like, oh, I was so good at that. I was so good at that part. So we could move this decimal over. And so we would get, this is 50% of the distribution on that side, 50% on that side, or the whole thing will add up to 100%. Right? If we look at this over here, what this is telling us is approximately 49% of people are in between the mean and a z-score of 2.37. There's less than 1%, is in the tail beyond that z-score. Okay, and the same thing would be true on the other side. About 49% of people are between the mean and a z-score of negative 2.37. Okay, so just some fun things with the normal distribution. These percentages like this, or when you hear it like this, when we say 49%, this is where we'll start to get into talking about percentile. Okay, and I'll save that. I won't start talking about that yet, okay? But this is where that comes from. Okay, these proportions can all, you just take that little decimal, plop, plop, plop it over 2 spots. It's saying 46%, okay? About 46.1%, 41%, okay? What do you guys think? Like this, or Where are we?
So do you want us, what do you want us to know in regards to like the percentage wise? Like, did you just want us to know that each side is going to be like the same, what you do on the same thing you do on one side is the same that you do on the other side? That was your idea?
Yeah, and it gets to like, okay, let's see, for example, let's see, I'm going to take out this stuff over here. Take it out. Why won't it do it? I don't know. It won't let me do it. Let's say we had a question here. Oops, now it draws. If we had a question here and we said, given a z-score of negative 1.85, what is the proportion to the mean and what is the proportion, oops, beyond the z? I don't know. So this one, right, we might have one like this where we have a negative. Okay, so let's go over this real quick. 1.85. Okay, so we're looking at 1.85 and we're looking at these numbers right here. Okay, so oops. What would we put right there?
Would it be the 0.4678?
That's exactly right. And I'm so glad you said that, because I didn't want you to say, negative 0.46.
So you're kind of disregarding the negative in a way.
Yeah, because we can't have a negative percent of people.
Mhm.
Right? So even though these people, all these people that are below the mean, even though they have a negative z-score, they still exist, right? They still exist. Forrest Gump was down there, right? He still exists. So we still have a percentage of people. We would not have a negative percentage of people. So yeah, so our values right here, isn't that weird? Now it won't let me, I don't know what's going on with it. It won't let me draw. Oh, here. I was like, it won't let me type. Okay, and then right here, we would get that 0.0322, right? I started bringing up the percentages because this is where we get percentile and stuff like that, but we won't talk about it today. Okay, and we'll save that. But this is where, this is the fun stuff that we have here. I mean, why is that there? Right now, I think we're just, let's be concerned with knowing everything that we just learned. Okay, that theoretical distribution, as you can see here, it's mathematically defined. Those numbers are set in stone. They're never going to change. We know that there's a proportion of observations or people, if you want to think of it that way, within. Okay, here. Z column is always your, or A column is always your Z scores, B column, and it even tells you here, right? If you see this right here, it even tells you, right? There's a little hints. All right, it tells you from the mean to the Z. C column is the Z to infinity, right? And then it gives you a picture here. B column is this one, C column is this one. If we're talking about a negative Z, B column is here, C column is here, okay? So there's little hints along the way, all right? None of this stuff would you would never try and memorize this stuff, okay? On the test, you always would have access to this table. No one would ever memorize this, okay? So you would always have access to this stuff. So right now, all I want you to do, I'll put up an assignment, and it might just be something super simple where you just, I'll try and make it in a quiz format, so then it's a little easier to answer, but just know it's not really a quiz. It's homework. You would have unlimited attempts and things like that, but it would just be practicing picking out numbers and kind of messing with this distribution. Okay.
Would we be using the pages that from this that you showed us?
Yeah.
Okay.
Yeah, 386 and 387. Okay. Yeah, you can't see them on mine because I covered up some of the stuff on mine so you wouldn't see it, but like this is another table we'll use eventually, and you can see I even write in it. You know, this one will be a table we use a lot when we do t-tests. And then it goes on, and then I write on these, right? And I make copies. I would make copies of these for my students. So this is no secret. You know, this stuff you have to look up. There's no, you know. So yes, have those out, have them, you can even put little stickies, you know, if you wanted, or bookmark it in some way, so that you know exactly where that table is. Okay. Yeah. our Z table. That's our first table, you guys. So that's why I just want you to learn how to find those values and just kind of understand what this normal distribution is. Right now, I'm comfortable with you guys just getting this down. Okay. All right. Yeah. Okay. And I'm gonna, let's see, it's about an hour and 15 minutes. You know, tomorrow, I don't know, I'm starting to realize that I don't know if I should constantly just do the same thing on Tuesday and Wednesday, but maybe tomorrow we can go in a little bit more on some of these other things. Okay. But I don't want that to scare anybody who can't come tomorrow. Don't worry. Okay. So any other questions from this so far? No. Okay. All right. You guys have a great day, a great Tuesday. And I will see some of you tomorrow. And if not, I'll see you next week. Okay. All right. Bye,
All
guys.
right, thank you.